Yeah, localized. Localized. So, like, there are three types of localized corrosion. These are pitting, crevice corrosion, and filiform corrosion. Pitting happens when there is a hole, small hole in the metal. Yeah. And the corrosion localized. So, like, there are three types of localized starts to spread and deteriorate. Corrosion. These are pitting, crevice corrosion, whatever. What else? Crevice corrosion frequently happens to in the stagnant microenvironment, like under, under beneath the gasket or flames, and can be caused by acidity or toxic pollution inside the
내가 원하는 퀄리티네.
The third one is filiform. This happens when water breaches the coating of the metal, and then the corrosion, and then it spreads. This usually happens when there are flows in coatings of the metals. Next, galvanic. Can you explain me this kind of corrosion? What is galvanic corrosion? Suggestion?
The big one.
Okay. So the two separate metals are placed in electrolyte, in the medium of corrosive electrolyte. So what happens is that this creates a galvanic couple between the metals, and so one metal is now cathode and the other one is anode. So now I'm going to say one thing. Is that the metal that is now the anode corrodes quickly, while the cathode corrodes slowly. Like it's the opposite. In the cathode, like there is like almost like no corrosion. What is the reason for that? Like why corrosion is stronger in anode, and on the cathode it doesn't really happen. Like yes. Right, like the oxidation in galvanic cells, the oxidation reaction happens on the electrolyte, on the electrode, which is anode, right? So, and by definition, corrosion was like due to oxidation reaction. So, by logic, on the anode, corrosion should be much stronger. Next one is environmental. So, environmental corrosion is due to environmental factors like temperature, chemicals, and stress. Next one, flow assisted. What is flow assisted corrosion? What is the most common flow in nature for us? The two types of flows.
Yeah.
So wind and water, they dissolve the protective oxide layer in the metal, and then they start the corrosion starts inside the metal. Next one is intragranular. Can you guess what this means? Okay. Intragranular is due to the impurities in the metal, and so corrosion happens in the grain boundaries. This is an interesting one, the alloying. So what is the alloying? Like we have alloys, right? And in alloys, there is main metal and other chemical elements. So the alloying, there's no more. So why is this
컴퓨터에 중가를
corrosion to protect one of the chemical elements inside the alloy. So due to this, like no more alloy, so it's the alloy. Writing this one happens when and there is relative motion between them, and oscillatory is usually vibration, so this is due to it.
Right. So today we have a second class on ocean renewable energy by myself and Sunghan. And also we have two discussions. This time I would like to start with class and then go on to Puya's discussion, and then if we have a time, general discussion together. No time, then can be moved down, right? This way. And next Wednesday we will have a second textbook on shipbuilding, and general arrangement is the first chapter and goes on with any question schedule, right?
So the exam is later last time.
Right. Do you have any conflict on the schedule? Usually there's another fixed schedule for any class. I would like to do in class time if you don't have a conflict.
If you have a conflict, we should find out the fixed time schedule provided by the KAIST Central Administration. So no conflict yet. And we go on more class time. So I will start with my
share agency. Meeting age,
right. So renewable energy part 3. And right, this time I will cover the current energy and thermal energy, two types. Right, I copied this one from two different sources so that you may see that there is some differences. On top there is a wind. They are saying watt per square meter power density or energy density. I told you about this one, right?
energy density. It is important. And wind is about 2. Here they are saying 2.5. So there are some. No, 1, about 1. There is 2.5. So depending on the source, there is some changes, differences. Also, the solar. Solar is about 10 or 15. But here say two numbers. It means about 7 to 8 watt per square meter. So because they are more separating out concentrated typical solar PV panels, there is also concentrated solar power, desert area. That means this one number, but this one is higher. So almost 20, what is 10. But there are some variations. Anyway, step. Right. So solar is more high capability and wind. And then current energy, there is a ocean current. There is 2 types: surface current and deep ocean current. and surface current is coming from wind. And together with the Uckman spiral effect, I told you about this one at the beginning of this class. The Uckman spiral effect, they have a drifting, so that wind is blowing this way, but current is moving this way. But it is spreading out towards the depths of the water. The secondary flow is behind. So the depth of this surface current is about up to 100 meters from the surface, up to 100 meters down. So 100 or above, between. And this is usually coastal current near continent. So it's a main surface current. One of them is Kuroshio, near Korea and Japan, and Taiwan and Philippines. And deep ocean current is coming from density and temperature gradient. So it is very slow, lower than this one, but it is more global scale, bigger, large and slow and deeper also. So flow under the surface of the ocean, deep ocean, as a current. So two different one. There is a color shows warm stream current and cold stream from the poles, North Pole. Current energy, ocean current energy potential. Ocean current speed is slower than wind, but the density is 100 times higher. So that 12 miles per hour ocean current would have an energy equal to or greater than 100 times winds. Right? So Gulf only 1,000 of energy of Gulf Stream could satisfy 30%, 1/3 of the whole energy mix. It's a big energy, but it's not easy to capture. Near the Korean peninsular current, especially from Kuroshio current. This is Kuroshio written in Korean. So Japan is here. Japan, Korea, China. So this is Yellow Sea, China and Korea. It's a very small portion. The mainstream is going east of the Japan. Right. So Kuroshio current is, where is it?
So Japan. This is Japan. Korea is here. So Kuroshio is going in this way, up, or near the Japan is the mainstream, but some of them is between Japan.
And also we already see this one. This one is NASA satellite image. But they have captured many static images and then combined them into a moving picture. Very beautiful. So you see that Japan and Korea. So this can be a Kuroshio current in Philippines. So they may have a good quality of current energy near Taiwan, near Philippines, and near Japan, rather than Korea. Korea only have a small portion near the Jeju Island and Busan Port. Current energy, submerged turbines, similar to wind turbine, right? Similar to wind turbine. Shapes. Fastened to the ocean floor. Ocean floor is here. Two types. One is horizontal axis. Axis is rotational axis. Is horizontal. Rotational axis is vertical. There is a standard. So where is the rotational axis? So horizontal and vertical. Those are also same as a wind power. Wind power also have vertical and horizontal. So this is a horizontal type.
And parachute type. This is a parachute shape. So they need a cable fastening to the bottom of C, cable to the ground of the seabed, allowing the turbine floating above the bottom of ground, operate much like a kite. So a series of kite, many kite continuously rotate. Right. This is the existing current power generation system. So you see that many of them are from UK. Different types. What size? The smaller megawatt is big, right? Big size. Small, too smaller. And also US, this is a river, not ocean. And Canada has a smaller one. So we can expect that ocean current is important for the implementation. Right. This one is from Japan. This is a lower part of the Japan is made of big islands, and lowest one of the four is Kyushu Island. And Tokyo is in the biggest main island that we call the Honshu. Kyushu is near Busan or Korea. There is a small city called Nagasaki, and there is also, this is Nagasaki, and then there is an island near the Nagasaki. So between small island, they put this one, but this one is 2 megawatt, diameter 16 meter. So it's big, rather big size. RPM is slow than wind power is made of very similar to wind power system, generator, gearbox, and pitch control and blade. Right? Why do we need a pitch control? Somebody can answer. Why do we need a pitch control? Pitch control or blade? Nobody? Yes.
To prevent from
bending too much from what? Against wind. But this one is current. Yes. So for the wind power, there is a typhoon is coming, then the blade can be broken because of the high wind. So they want to be escaped, so that they use rotational. The angle of attack is lower down to minimize the wind power. This time, this is current power, so that water instead of wind, right? Same logic. So they want to control the pitch to protect the blade. Because the current also can be very high sometimes. Usually not. But because the current is usually steadier than wind power. Wind is very blowing, fluctuation is higher. The current is rather steady. But anyway, they need this kind of one. Current energy, where is this? 3 major current in USA, Gulf of Mexico, Florida is near. This is Florida. This is Gulf of Mexico. And California is west. So California is here. There is a current, good current there. There is a video, but I will not show you this time to save time. Oh, summer energy. Summer energy, 2 types of summer energy, geosummer, the land side, and ocean summer from the water side. So this is geosummer energy. So deep down into, say, kilometer down, there can be a bit hot melting pot there. So high temperature there. Ocean temperature usually use a very small temperature difference. Sometimes there can be also similar one like this one, bottom down. Then you can use let me show this video this time.
I suppose that you're writing a really important email to a colleague.
It's short, 1 minute. So hot water is here, cold water is here. Only temperature differences. And heat exchange using ammonia. Okay. So ocean thermal energy conversion, top layer of ocean receives solar heating, so warm water there. Bottom layers receive water from the polar region, so cold water deep down. So natural temperature gradient, very small. So anyway, they use thermocycle generated electricity. Simple idea. How to use geothermal energy? This is land side usually. Sources, if you have not so hot water, they use building, heating, air conditioning, industrial, dry greenhouse, something like this. So fish farm, greenhouse, and crop drying. And if you have hot water there, simply because of the hot geothermals, then you can use this one. Pressurized water coming and you can make electricity out of them. But sometimes they can produce gas, not good gases, chemical gases coming together. So high temperature is going on, hot blocks or heating pump. And so it's a hot water, then binary cycle plant. So it is a lower boiling point, and also they can use a turbine, it's rotating, and generator to provide electricity. So Casa Diablo, maybe near California somewhere. Yes, there is a plant there. Okay. Right? Question. And hand over to Sumhan. 취해서.
Dragging snot.
Okay, good afternoon. This is my lecture time. I am Park Seung Han. Yesterday we took a class about the ocean renewable energy, part 1, such as wind, tidal wave, and also today part 2, current thermal. And our topic is part 2, the solar energy and biomass energy sources. Solar energy comes from the sun, and this energy scale is very big. The solar energy will really big energy potential than any other renewable sources. As you can see, only 0.02% of available solar energy could replace all other energy resources because of reflection and radiation from Earth. And as you see this picture, you can know how big the solar energy is. And then, so energy radiated on the Earth in 1 hour is greater than or the energy the world uses in a year. And you can think solar energy is very big and wide. And then solar energy technologies. The solar energy is not easy to convert to electricity because of the density. To take energy from the sun, there are good technology to get a solar energy like this. Solar energy technology, daylighting, passive solar lighting, active solar lighting, concentrating solar thermal, and photovoltaics, PV. The first thing is the passive solar energy, like this. At first, light is coming outside. This is there no additional material to get the solar energy, but the most key design point is locating the house, like this picture. It does not involve the use of mechanical and electrical devices. So this home in Montana and California with a passive solar design heat, the home in the winter and cools the home in the summer. This is passive solar. And the second thing is the active solar lighting. There is circulation pumping. As you can see, the plate is white. Okay, active solar lighting is the case of the plate is used. The plate is used, but this is only for heating, not for electricity. Different method. And water is circulated to make heating inside in the house, like this. The boiled water is heated during the daytime. Heating water is circulated throughout the night. For example, in desert area, the temperature difference is so big during the daytime and nighttime. So we can think, so it can be cooler and colder in the nighttime, and we should add small tools inside. Their anti-freeze solution is used for automotive to work well. And the next we focus to PV. PV means photovoltaic, like this. It was mentioned from the video. Let's watch the video about PV.
The Earth intercepts a lot of solar power. Power, 173,000 terawatts. That's 10,000 times more power than the planet's population uses. So is it possible that one day the world could be completely reliant on solar energy? To answer that question, we first need to examine how solar panels convert solar energy to electrical energy. Solar panels are made up of smaller units called solar cells. The most common solar cells are made from silicon, a semiconductor that is the second most abundant element on Earth. In a solar cell, crystalline silicon is sandwiched between conductive layers. Each silicon atom is connected to its neighbors by 4 strong bonds, which keep the electrons in place, so no current can flow. Here's the key. A silicon solar cell uses 2 different layers of silicon. An N-type silicon has extra electrons, and P-type silicon has extra spaces for electrons, called holes. Where the 2 types of silicon meet, electrons can wander across the p-n junction, leaving a positive charge on one side and creating negative charge on the other. You can think of light as the flow of tiny particles, called photons, shooting out from the sun. When one of these photons strikes the silicon cell with enough energy, it can knock an electron from its bond, leaving a hole. The negatively charged electron and location of the positively charged hole are now free to move around. But because of the electric field at the p-n junction, they'll only go one way. The electron is drawn to the n side, while the hole is drawn to the p side. The mobile electrons are collected by thin metal fingers at the top of the cell. From there, they flow through an external circuit, doing electrical work like powering a light bulb, before returning through the conductive aluminum sheet on the back. Each silicon cell only puts out half a volt, but you can string them together in modules to get more power. 12 photovoltaic cells are enough to charge a cell phone, while it takes many modules to power an entire house. Electrons are the only moving parts in a solar cell, and they all go back where they came from. There's nothing to get worn out or used up, so solar cells can last for decades. So what's stopping us from being completely reliant on solar power? There are political factors at play, not to mention businesses that lobby to maintain the status quo. But for now, let's focus on the physical and logistical challenges. And the most obvious of those is that solar energy is unevenly distributed across the planet. Some areas are sunnier than others. It's also inconsistent. Less solar energy is available on cloudy days or at night. So a total reliance would require efficient ways to get electricity from sunny spots to cloudy ones, and effective storage of energy. The efficiency of the cell itself is a challenge too. If sunlight is reflected instead of absorbed, or if dislodged electrons fall back into a hole before going through the circuit, that photon's energy is lost. The most efficient solar cell yet still only converts 46% of the available sunlight to electricity, and most commercial systems are currently 15 to 20% efficient. In spite of these limitations, it actually would be possible to power the entire world with today's solar technology. We'd need the funding to build the infrastructure and a good deal of space. Estimates range from tens to hundreds of thousands of square miles. Which seems like a lot, but the Sahara Desert alone is over 3 million square miles in area. Meanwhile, solar cells are getting better, cheaper, and are competing with electricity from the grid. And innovations like floating solar farms may change the landscape entirely. Thought experiments aside, there's the fact that over 1 billion people don't have access to a reliable electric grid, especially in developing countries, many of which are sunny. So in places like that, solar energy is already much cheaper and safer than available alternatives like kerosene. For, say, Finland or Seattle, though, effective solar energy may still be a little way off.
Okay. In the video, it has a problem to send the electricity to the other side of the water of the world through the cable. This also will cost the big money. So there is a lost efficiency of transmission. But many researchers are working to solve this problem. Okay. And the other property of photovoltaics, as you can see, photovoltaic system converts sunlight directly into electricity. And photovoltaics is also used for power supply in small calculator or wrist watches we use every day. And the next concept is concentrating solar power. Okay, as you see, mirrors direct sunlight on one point. Water is turned into steam with this heat. The steam turns a turbine to create electricity. The concentrating solar power focuses on high temperature heating. Electricity is generated when the concentrate light is converted to heat, which drives a heat engine. Usually, we call the boiled water steam turbine connected to an electrical power generator. Okay, this topic is aquatic biomass energy. This is another topic. So, water is needed. Watch the video related to aquatic biomass energy. Just 1 minute.
What is aquatic biomass? Aquatic biomass is made up of microalgae, seaweeds, and marine plants. By photosynthesis, it produces half of the oxygen we breathe. We can use aquatic biomass as a base for many useful things, such as chemicals, inexpensive biofuels, and food, including more valuable omega-3 oils. Aquatic biomass is great news for a bio-based society. Why? Creating products from aquatic biomass does not require a lot of fresh water or agricultural land, and the produce is CO2 neutral. Take fuels, for example. The CO2 released upon combustion is withdrawn from the atmosphere by the existing aquatic biomass. This drives the photosynthesis process. If we want to produce aquatic biomass in our oceans on a large scale, we still have to solve a lot of biological, technical, and infrastructural problems. At Delft University of Technology, we take this challenge by working on cultivation processes that are robust and simple. If you want to find out more about ocean energy, go to the Delft University of Technology Ocean Energy website.
Okay, as you know, you can reduce your area because it does not need the agricultural land in the land side. To reduce the land utilization is the use of water environment of the property about aquatic biomass energy. And visualists are interesting can-based coupling water treatment and aquatic biomass growing. As such, aquatic biomass energy is an emerging theme. Likewise, municipal and processed water can be used with the additional benefit of water treatment and better resource utilization. And next, this table means the comparison of some sources of biofuel. The cropping area in the United States has the lowest value in case of microalgae. And this is a picture of the algae farm. Maybe you have already seen of this green algae. It is located some in natural lake or some artificial lake. Algae is the simple photosynthetic organism that could be helping our biofuel, and this is how to gather aquatic biomass. The aquatic biomass is made up of some marine plants or microalgae and seafood. This kind of biomass can be used for even in food or biofuel and so on. Okay, and this last picture is how to gather our aquatic biomass from the ocean, like this unit growing and like automatic system about ocean aquatic biomass energy. Okay, it's over now. Do you have any question? Okay.
The biomass farm that you showed the slide before, this already exists?
Yes.
Yes?
Clearly exists. Maybe in US too. Okay. Thank you.
Okay, continue discussions. Good timing. Is it right? Is it? I think it's we don't see. So five
No, it's
Good afternoon. My name is Puya. This is a continuation of the lectures that someone gave. So I'm going to talk about ocean renewable energy and the storage technology, mostly the storage, the problems of the storage. First of all, can somebody tell me what has happened basically to the demands and regulations with regard to energy? Has it gone up, down? Two choices. So the demand and regulations for energy in the world, has it gone up or down? Oh, good. All right. Has anybody heard of the Green New Deal? Have you? So can you tell us what it is?
So basically, there is this young Democrat in America, Alexandria Ocasio-Cortez. Yeah, she wrote this book. I guess it's a book, but so it's about starting policies for changing energy infrastructure. But the book itself is written in really amateur way, I think, because like she doesn't realize the economy of the stuff, and like she learns the big words, but it's not based on the.
So it's not detail oriented. That's what you're trying to say.
Yeah, like it's not professional.
Well, that's fair. That's not part of the protest. But the Green New Deal basically tries to supply all the energy needs in America, 100% of it with. They try to basically cut the carbon emission by 45% by 2030, which is like in 10 years from now. So that's the technical part, that there's a lot of problem with that. They're trying to basically control the global warming by keeping the change down to 2.7 degrees, and they say that meanwhile you can create jobs for 10 million people. But as far as there's a lot of technical problems with it. I like the spirit of it, but like you said, there's a lot of technical problems that I won't have time to get into here. But if you're interested, you can look it up. It's actually very, very interesting. So, what are the methods for ocean renewable energy? You can use basically the pictures here as a guide. Okay. Say again. Oh. So offshore wind farm, wave energy, and tidal energy. The last one is tidal. So the pros and cons of it. What are the pros? What are the pros of tidal energy? That's pretty much the same thing. But yeah, it offers stable prices. It's environmentally friendly, as you said. It has job creation and it has low operational cost. So what about the cons?
Special constraint.
True. Yeah, it's site limitation. Yeah. Maintenance. It takes a lot of place. Site limitations. Else? It takes a lot of money to develop it at the beginning, so that's one thing. It's vulnerable, and as some of you also mentioned, it has a site limitations. You can't really use it in a lot of places. But in developing it, what are the challenges? What are the few challenges that you can think of in developing it? It has a high LCO and low efficiency. So can anybody tell me what LCO is? Basically, it's there. It's the sum of cost of over lifetime over the sum of the electrical energy that's being produced. So that's the biggest two challenges. And also a second challenge is what I mentioned in the beginning, which is developing a storage system for it. So how can we address it? How can we address that challenge? I don't want to think about it. Okay. So one solution is to use floating wind turbines. So can anybody tell me what floating wind turbines are? storage. Yeah. Okay. What else? So it's like independent. So as you mentioned, that's the most important part. So offshore wind speeds tend to be faster and steadier. So that's the greatest advantage that for them. And the greatest disadvantage is that, first of all, it's very difficult to build. And it's extremely unpopular among people in that area because it creates a lot of noise and also damage. So the second one, thermal energy conversion. So can anyone tell me how and the temperature difference between the cooler deep and the warmer shallow? So we talk about the questions. All right then, thank you.
Good. Good discussion. Audience is good for this one, right?
Thank you.
Also, we have enough time for next discussion.
talk about ocean renewable energy discussion and maybe share with him. First, we talk about renewable energy installation case in Korea. Installation condition is very important for marine renewable energy. So we first look at the installation conditions and check them out in our life. Then first, renewable energy is tidal energy. So what is the location condition about tidal energy?
Or difference of tidal range?
Yeah. Of course, the difference between tidal is
Needs to be near shore. Near shore needs to be can't be.
Near shore.
Yeah.
Oh yeah. Similar, but because the incoming water must be kept, so it has form of finally, also the ground should be strong enough to allow generate electrons. So the difference between type is important, and also cross waveform, and finally firmness on the ground. So maybe he is lecture about plants. So is mostly representative of tidal energy plants. So you can see that the site is closed. Next is current energy. What is rotation condition of current energy?
Locations at a high current speed, like between islands or.
Oh yes, the current speed is important. Anything else? So we want to use that current energy. So that current characteristic is clear. There must be clear current characteristics of current. So the characteristic of the current are clear, and also current speed at least like that. Uldomok power plant is representative of current energy plants, and its current speed is 11 knots, making it very suitable for energy generation. And here's how it looks. And finally, we look at wave energy. And what is location condition about wave energy?
I mean, we need strong waves, so probably in places where the winds are strong.
Also, strong wave is important. Yes, also. They use cable, so
These ones?
yes, they must be near the shore. Okay.
But yeah.
There are many types of wave energy, but we talk about fixed one. So the location condition is like that. The distance from land is less than 30 kilometers, and the depth of water is less than 300 meters. Also, finally, no obstructing Gaussian function because it's near the shore. So this is Jeju plant, but there are some problem about that. Can you know what is the problem?
Waves are too strong.
Yes, Earth's wave is so strong, and the cable underwater cable is because of the weather. They broken, so it is still necessary to develop a little more. And type 2 is pros and cons of renewable energy. We talk about solar and biomass.
permanent loading resources going.
Yeah. Sources. Sources. Yeah.
I mean, I guess no carbon emissions.
Yeah.
You may type down the ideas there.
Type down.
Why not? Collecting ideas.
So you say that bit. And then say
No carbon emissions.
pollution. What about this advantage of solar energy? Okay. Then fossil plants.
Storage.
Storage. Yeah, okay. That's awesome. Anything else?
High installation cost. High installation.
Okay. That's okay. That's okay.
It takes a lot of space. Then space.
Space. Oh. So you say that it has large space. Maybe.
It's not producing energy all the time. For example, the night.
Okay. Time constraint. Okay. So you say that maybe all of this eco-friendly permanent input resource and maybe low operating cost because it's when it can use small size. So then fossil plants it has low operating cost and ease of automation. Disadvantage is time constraint, spatial constraint, and low energy density, so require large footprint. And finally, we will talk about biomass energy. What is the advantage and disadvantage of biomass? It is opposite with solar energy.
Eco-friendly.
Okay. Eco-friendly. Talk about how high efficiency not yet. Maybe we make more efficient.
You can use your own waste. Use biomass energy, so you can reduce waste.
Okay, we can maybe it's done. It's less time and space constraint than solar energy. And when use micro energy, that effect of reducing CO2 because using short to cultivate that and eco-friendly. And disadvantage is not progress enough. Development is not progress enough. So high cost and low efficiency. This is reference. And do you have any question?
I mean, no.
Thank you.
I found the discussion is better than before, right? So we can improve every time. The timing is too earlier, so but anyway, I'm happy to get good discussion today, so we can close earlier.